How are you? I am fine. Yesterday we are discussing about sign conventions of spherical mirrors and mirrors formula and magnification of spherical mirrors. I hope that all of you understanding that topic. Today we are able to discuss the applications of spherical mirrors in daily life. Is here we have to discussing about example problems of spherical mirrors. Okay, now we have to speak about that. Let us start. Here some example is there. First we have to read the problem about concave mirror. A concave mirror has focal length 3 centimeters. Find the image position when a object is placed at 5 centimeters from the mirror. Here we have to understand what data is given first. So here the focal length is given 3 centimeters and object's distance is given 5 centimeters. Now we have to find the image distance. Okay, so we have to draw a picture as shown in the figure here. Diagram, you can observe the diagram. Here P is the pole and F is the focus and C is the center of the curvature. Okay, the image, we can find out the image distance. Okay, given data is F is equal to 3 centimeters and object distance U is equal to 5 centimeters. Here we indicate minus symbols is using the sign conventions. Okay, solution, we have to write the, we have to three terms in mirrors formula F, V and U. So here we know F and U. So we have to find the V value. Okay. Here first you mention them, you write them using mirrors formula. 1 by F is equal to 1 by V plus 1 by U. Here F is minus 3. So then substitute minus 3. 1 by minus 3 is equal V, we don't know V. So we can write that as usual 1 by V plus 1 by U. U indicates minus 5. So 1 by minus 5. Here we calculate V. So V is one side and the F is um, other terms are second side. Okay, so 1 by V is equal to 1 by minus 3 F value plus 1 by 5 is taken to other side of the equal to, then its value is minus, but here is minus, so minus into minus is plus, so 1 by 5 plus 1 by 5. Now we have to take LCM of 3 and 5, that is 15. So we can multiply and add using fractions rules. So 5 into 3, here is 3 5s are, so 5 into 1 is 5 minus 5 plus 5 3 is 3 into 1 3 minus 5 plus 3 by 15, that equal to minus 2 by 15. So 1 by V is equal to minus 2 by 15, then V is equal to 15 by minus 2, that is minus 7.5 centimeters. So here the distance of the image is minus 7.5. Now we can calculate the magnification also. So magnification M is equal to, we have the formula minus V by U, distance of image by distance of object. So image distance is minus 7.5. We indicate minus is front side of the mirror. Minus into minus 7.5 by object distance minus 5. Then both are minus minus cancel, then given minus 1.5, 15 jar. So minus 1.5. So magnification is minus 1.5. Okay. Here we conclude this problem. Since V is negative, image is real and formed in the front of the mirror. Okay, here. Since M is negative, image is inverted. That means real image. Okay. Magnification M is equal to 1.5 is greater than 1. So image is magnified 1.5 times bigger than the object. Okay. So we have to understand this problem. In concave mirror, image is real, inverted and magnified 1.5 times. Okay. This is a problem 1. Example 1 is discussed. Okay. I hope that all of you understand this problem. Now let us know another problem. Example 2. Here an object 4 centimeters high is placed at 25 centimeters in front of a concave mirror of focal length 15 centimeters. Find image distance and image height. Here we have to give object height is 4 centimeters. Placed at 25 centimeters front of concave mirror. Then it gives object height and object height of the object distance from object side, and the distance of object also given 25 centimeters. That means U is given, HO is 4.0 centimeters, and height distance of the object is minus 25 centimeters. Because the sign conventions, concave mirror indicates minus sign. Okay, so we have to write the minus symbol in front of the distance of the object. Okay, and the focal length is also given 15 centimeters. So F is equal to minus 15 centimeters. It's shown in the figure. We have to draw a figure. Then we understand the what data is given and what data we find. Okay. Here 4 centimeters is height of the object. Okay. Then 25 centimeters is object's distance from pole. Okay, and we can find first our image distance. Okay, and image height also. Okay, focal length is given 15 centimeters. Solution: we have to write the formula using mirror formula. 1 by f is equal to 1 by v plus 1 by u. So here f is minus 15 centimeters. So we substitute the values in this formula. So 1 by minus 15 is equal to 1 by v plus 1 by minus 25. Here we calculate this formula v. So simplify by this formula. 1 by v is one side. We can write 1 by v is one side and the other side remaining values. So minus 1 by 15 plus this minus plus into minus 1 by 15 is here. This can be right in other side, it can be modified plus 1 by 25. So minus 1 by 15 plus 1 by 25. 15 and 25 have taken LCM. It is 375. Then we can write the table, use the table 15 table and 25 table. 15 25 is 25 1 is 25. Minus symbol is in front of the this focal length. So minus is indicated. Minus 25 plus 25 15 ja, so 15. So minus 10 by 375. Here we can write 1 by v value is minus 10 by 375. Then v is equal to minus 375 by 10. So that is 37.5. That is minus symbol is also indicated. V is equal to minus 37.5. So image distance is minus 37.5 centimeters. Now we calculate the magnification. So magnification M is equal to minus V by U. Here image distance is minus 37.5 and object distance is minus 25. In front also minus is indicated. So it can be divided. Then the magnification M is equal to minus 1.5. We can calculate another way also. Height. We need height. Image height is needed. We need image height. So we can write the magnification another formula. M is equal to HI by HO. Here HI we calculated. So HI is equal to M into HO. So HI is equal to M is minus 1.5 into HO is 4. So it multiply both, then get minus 6 centimeters. So image height is minus 6 centimeters. Here we find the object distance and image height both. Okay, all of you understand? Then conclude this problem. Since V is negative, image is real and formed in front of the mirror. Since magnification is negative, image is inverted. Magnification M is equal to 1.5. So it greater than 1. So image is enlarged. How many times? 1.5 times bigger than the object. Negative HI shows image is below the principal axis. Okay. So here the image is formed real, inverted and enlarged. Image distance is 37.5 and image height is 6 centimeters. Now I hope that understand this problem, my dear children. Okay, thank you. If you have any doubts, please ask me in comments. Please like, share and subscribe my channel. Thanks to listen my teaching. I hope that you share another people to reach my video. Thank you. Thank you so much. We will meet again in next class. Thank you.